Okay, let me get started. Please let me know if you can hear my voice. Hello, good afternoon. Okay. Hello, so this is Junichiro Horikawa. It's a live stream for Houdini, tutorial live stream for Houdini, which I've been doing weekly. And this is a 137th episode. And this week I'm going to create some setup using Vellum system to create a wrinkle growth system on any specific surface. And yep, let's get started. And thank you, Raphael, for the super chat. Appreciate it. Thank you for saying that. Okay, so the basic idea that I'm going to do today is to create a wrinkle on a surface just like these, just like you see on a painted surface, a defected painted surface. You might have seen something like this on a coated surface, maybe on a car or something like that, or on the wall where some paint's being defected like these. So this is what I would like to simulate today using Vellum close simulation, which is pretty easy to do as a setup. So I think it's pretty versatile. I mean, generally useful for some things like these shapes or conditions or statuses. Okay, so the plan is to first of all create some geometry you want to modify as a surface, and then create some mask on top of a surface where you want to create a wrinkles, just like these typographies. And then I'm going to set up some forces for Vellum, which in this case I'm going to use cloth and a glue forces or constraints. And that's pretty much it. I'm also going to set some solver inside the Vellum solver, but which is going to be pretty simple one. And that's pretty much it in terms of the setup. And then after that you could like try out any kinds of like masking. The mask could also be animated just like these. You can transform from one mask conditions to other conditions, making it possible to create a morphing or wrinkle morphing, which might be interesting. So that's what I'm going to try to do today. Alright, so let's do this from scratch as always. Alright, let me save the file first then. Okay, get started. So first thing first, since we are working on the SOP context, I'm going to create a geometry node. Then start off with any geometry you want. I'm gonna go with the sphere for now, which I could change it later. And let's make it polygon, and since we're going to create a kind of a detailed wrinkle simulations, I would like to have many polygons as possible. I'm gonna set the frequency to something like 60 or 70, maybe 70. Maybe I could start with 50 for now, later increase this if I think I need more resolutions. Okay, let's also create a controller, null node, where I can have all the parameters to control the setup, which in this case the frequency could be a parameter, but maybe I want to switch the geometry later, so I'm gonna leave it as it is for now. Okay, next, since I have the geometry now, I would like to create a mask on top of the surface where I want to put the wrinkles. I could do the typography, but to make it simple for now, I'm gonna try with the noise mask as a starter. Maybe later I'm gonna go back to create a morphing typography. But for now, to test out, using noise is a simple thing, so let's use noise function to create a mask using point wrangle. Okay, so first of all, let's create a value called mask using noise function based on the point position, as well as multiplying with some noise scaling value to control the size of the resolutions of the scale and which will give you a volume between around 0.3 to 0.7, so I think it will also be better to fit or remap this value to something in between 0 to 1. So I'm going to say something like 0.4 to 0.6 to 0 to 1, which I think will forcefully create a value 0 and 1 at some point. Let's check this out. I'm going to create an attribute called mask, apply this mask value, and try to visualize it, see how it looks like, which is going to be used as the intensity value for the wrinkle. Now, doesn't really look noise function as it is. So let's promote this scale value that I have here and change these value to see if I have more better value here. Okay, so looking good. So maybe I can say the white areas will be having the wrinkles, the black areas will be smoothed. And let's increase this value a little bit. And maybe I could also animate this so that I could test out this animated wrinkle pattern later. So let's also give some animations to these noise function, which in this case I think it's better if I have 4 vectors instead of 3 vectors as a seed for the noise, so that I can use the 4th value as a time base value. So let's create that. First thing first, I am going to create a positions, which I'm going to multiply the positions with the scale. Then for X, Y, and Z, I'm going to use this position, and for the Z value I can use a timeline based value, which could be parameterized as well. Okay, then I can replace this noise value, noise seed, with this seed It has to be vector 4. See what happens. And if I change these t value, I can now animate these noise map. Now I can use a frame-based value here, something like FF. See what happens. That's too fast. Maybe I can divide fend and multiply it with some additional value. Okay, maybe that's too fast. I'll just go with this multiply by 1 value so that it goes from 0 to 1 from frame 1 to the end frame to test out. So in this case, I would like to use the white area to be having more wrinkles and black areas to have smoothed areas. Okay. And if I want to control more like black areas or white areas, I can do it somewhere around here by subtracting some values plus or minus. Yeah. In this case, I think it makes sense to make subtract by some positive value to have small areas of wrinkles like these. Okay, looks good. Alright, now that I have these values, what I would like to do next is to or maybe I can place this somewhere here. Other way around. Maybe here. Nope. Should be positive, I guess. Nope. Yeah, this will do. Yeah, I think this is better. Okay, looks good. Now, what I would like to do next is to use this map, the mask value, to specify, use it as a strength for the wrinkles. But in order to do that, I need to have a constraint for Vellum at this point, so I'm just gonna go create this constraints now. Now let's remove this color for a bit and create Vellum cloth, starting with the cloth. I'm gonna go with the default value for now. I might need to make the bending a little bit smaller later, but for now it's okay. Yeah, just go with these, and I'm going to create additional Vellum constraints, which is in here. There is a one called Vellum glue, where you can create a some constraints between 2 points with some strength, just like the clothes' string or stretch functions, but by being able to specify the points. Now the glue that I want to create on this is the one on each points on the surface, and I think I need to explain how this setup will work. So let's look at the sections of the geometry, and you have a point on the surface, right? And you're going to create a virtual copy of the surface. And you also have a real geometry, which is overlaying to this copy, which has the same point positions. Right. What I'm going to do is to simply create a virtual constraint lines between these 2 points. And while doing the simulations, while on the simulations, what I'm going to do is to stretch or extend the length of the original geometry, which is on the top in this case, which is this one. Meaning you are going to keep the copied geometry as it is on the bottom, but the original geometry is going to be expanded. The edge of this new geometry, which in this case these edges will extend from the virtual copy. Which as a result you're going to have some defects. You're going to have some waves on a surface. But if you don't have any other constraints other than these lengths or the cloth constraints, what you're going to get as a result is something like that. But in our case, what we want to have is something like these, having a wave close to the original surface, close to the original copy of the surface. To do that, that's where I would like to use these glues. By having some constraints between the original and the copy, you could pull the points which goes too far from the original, make it back, go back to, close back to the original positions, which is in result you're going to have 2 constraints balanced together. One is this extended length for each edges where you have a wrinkle, and you also have these glues which tries to connect 2 points together. As a result, you're going to have a defected paint-like surface, like a wavy surface or wrinkle-like surface on as a result. Okay, so that's the plan. So what I would like to do here is to create this glue constraints between the original and the copy. Okay. So I'm going to create a copy of this geometry, which in this case I just need a points, which will not be affected by the simulations, which means it's not going to move. It's going to be fixed where it is during the simulations as a anchor point for the simulation. So let's have that by using, in this case, using delete node, and just get those points. I need to need to delete primitives and just keep the points like these. So this is going to be the copied geometry of the original, which is this one. What I would like to do is to create a constraints between these points which belongs to the surface, and those copied points, which is not going to be moving by the simulation. Okay, so to do that, we need to merge these two geometries together, but in order to know which one's which, I'm going to create some group between those two points. One, I'm going to call this glue points, just glue. Another one, I'm going to call these base. Okay, and then merge these together. So you're going to have a overlaid points to each other. One is these glue points and one is the original base points. Now the cloth constraints only works with the meshes, so I don't really need to care about these glue points. But when it comes to these glues, this is where you want to work on where you want to create a constraints between the base and the glue. So let's set it up. Okay, first thing you do is to look for the parameters. So the first parameters you need to do is to change these group type to points for the geometry and set base for this one. Now you have the base. The next thing you need is target, and the target geometry here is again the points, and you're going to look for the glue points. Now you also need to search for a specific points for each base to have a corresponding target, and you have this option where you can search from the base with specific search distance or search radiuses, and currently it's pretty much overlaid. The distance between those 2 points, base and glue, is really close to 0, so I can just set this max search distance to small as possible, like 0.001 which is enough. If it's too big, it might find another points, another neighboring points, which is not what I want, and I just need 1 point to be the result of the searching. So just set this to 1, and that's pretty much it. All you need to do now is to set some stiffness for this constraints which I find out that making this too big will not create wrinkles, so it needs to be as small as possible to create some chance to get wrinkles go off the original surface. So in our case, I'm gonna test with 0.01 for now. Maybe I'll go back later to change these value. Okay, so that's a setup that I'll do on the glue constraints. And in terms of the constraint, that's pretty much it. Now, one thing that I need to do is to make these glue points not affecting the other simulated points. Like as a default, these points is going to be used as collision points, which is not what we want. We want to ignore the collisions on those points, and we also want to fix its position where it is, and to not be able to affect it by simulations. So we need to set some attributes for these points after we have set the constraints. So to do that, I am going to use the point wrangle to set some specific attribute for Vellum, which in this case I'm going to set 3 attributes, 4 attributes maybe. One is a mass attribute, which is going to affect how fast it moves. If I set it to 0, then it's not going to move anymore. And I specifically have to specifically have to say that the glue group point won't be affected by those functions. And another one, I am going to set a disable self, which is related to collision. So I'm going to disable all the collision related attributes. And the third one is disable external. And finally, I'm going to set a string attribute called collision ignore to ignore the collisions from everything. Okay, so I found out this is what I need in order for these glue points to be not affected by affecting the simulations. Without having these points going to affect how the original clothes simulations being done, which as a result makes some self-folding or self-intersecting result, which I don't really want. So I think this is necessary for my setup in this case. Okay. Can I have a comment? Have off-topic questions but inspired by wrinkles. Can Fourier transforms be applied on a spatial geometry to consider it as a frequency that can be sorted and modified separately? Ah, interesting. Could be, yeah. I think so. I mean, theoretically it should be possible, isn't it? I mean, could be applied on a 3D wrinkle surface as well for those Fourier transforms. Don't specifically know how, but I think it's theoretically it's possible. Maybe it's interesting things to try out in the future. But I like the idea. Where was I? So now that I have set the Vellum constraints, let's also create a Vellum solver to test out the simulations. I mean, I haven't set any forces yet, but I could do this inside a solver for that. Okay, so connecting all the inputs to outputs. Let's also remove the gravity for this one. And I don't really need the floor. Do I have it? No. Okay, so I think this is okay. So these attributes, like disable self and disable external, corresponds to the value right here. Okay, so you can specify some points to be not affected by those toggle choices, which is pretty useful, I think. Okay, now that I have all the setup for a Vellum, let's go inside the solver and write some functions where I would like to extend the lengths of each edges based on the mask value on a surface and through time. Okay, that's what I would like to do. So let's do this. So in order to do that, I am going to use a subsolver node, which I can use again the vex functions. Now I don't want to change the geometry itself, but instead I want to change the constraints instead of geometry. So I need to change this data name to constraint geometry. and that will update the constraint geometries when I did some updates on this solver. Okay, and you get the constraints edges from top geometry, this input. Now I can use a wrangle to modify something like rest lengths and stuff like that. So let's do that. I'm going to modify the primitive wrangle, primitive attributes for this constraints, which has all sorts of informations. In this case, what I would like to do is to extend the lengths of the edges, which is affected by the mask, and which is related to this rest lengths attributes for the stretch group, which comes from the cloth Vellum constraints. So create the primitive wrangle, apply this code to stretch, which controls the lengths of the edges, and then write up some code. Okay, and in order to specify how much it should be extended, I also need the mask information. So let's get that mask information externally, which I have it right here, which changes its value based on the time, like this. So let's connect this information or geometry to a null node called noise map or something, and let's try to get this information inside a solver, inside a Vellum solve. Okay, so just going to use object merge. I'm going to import the noise map from the geometry node network, which I can do that from here. Okay, now let's connect this to a second input of this primitive wrangle and write some code on this primitive wrangle based on this noise map. Okay, so first thing first, I would like to get this mask information from the second input. If it's white, I got higher value close to 1. If it's black, I will get a value close to 0. And based on those values, I would like to change the scale, how much the edge extends, which will become a wrinkle in the end. So let's get that by using something like UV sample function. Get the mask information using the point as a UV or searching attributes. The at P in this case will be the center of each edges, which is okay, I think. Now, based on this mask value, I would like to use it as a scaling value for the edges, which defines how much it extends. So let's say float scale is equal to fit 01 mask. So if it's close to 0, I want to make it smooth, which in this case 1 as a scale value. 1 means no scaling, so stay as it is. And if it's close to white, then let's make it 2 for now. So the edge length will become second times bigger, 2 times bigger. Okay, now in order to use this scale value, I can now update the rest lengths by multiplying the rest length original value, which won't change during the simulations, which is fixed to the initial value, multiplied by the scale. Yeah. Okay, and that's it. Let's see if I got these values right by checking out the color of the distance, color of the stretch constraints, if I'm getting the right mask value. Okay, looks correct. So the white area should be extended, black area is going to be stay as it is. Okay, save it and see what happens. Okay, now if I play it, okay, that was fast, but yeah, I already get these results. The reason why it gets fast because I didn't make gradational transitions from black to white. I mean, initially it's all smooth, but suddenly you're going to have these wrinkle areas as white, which makes it too fast to appear these areas. So maybe it's better if I also introduce some frame-based transitions from smooth to wrinkle. But let's see what happens, if it's going to be affected by the noise map animation. It does seem to change the position of the map, but it's not really obvious. So let's make the speed of this noise map changes a little bit faster, multiplying this by 3 maybe, which is fast enough, I think. Okay, let's see. Let's try with these and see what happens if I play it. And yeah, I think it is animating or moving. Probably. Yeah, I think so. Yep. So, I mean, basically, this is the whole idea. I mean, other than this, you're just going to apply many conditionals to make it more controllable in terms of the procedural setup. But the basic idea, the basic algorithms is this. Simple as that. Okay. And you can modify these glue strength, glue stiffness, or close bending value to change the detail of this wrinkle. If I increase the stiffness, or maybe if I increase the or decrease the bending stiffness, currently it's 0.0001, but if I change to something like these, I think you're going to have more wrinkles like that, which is maybe too much for this resolutions. If I increase this of it 1 decimal up, yeah. So those value could be controlled, could be used to control the resolutions of the wrinkle, and you could also use the wrinkle map as it is as well to control the position of the wrinkles. Okay. I mean, you could also use another map to control the resolutions as well. I mean, control the stiffness itself with the attributes, which might be interesting. So maybe I'll try that later. But for now, what I wanted to try next is to introduce some transitions from smoothing, the very smoothing conditions to wrinkle state. which is pretty easy. I mean, you just need to set some initial frame, like 50 frame or 30 frames, to be used as the transitional value. So let's have that. Let's name this t frame, make it as a integer value. Let's say I want to use the first 30 frames to be going from 0 to 1. I mean, to be able to use the mask itself. Let's set this to 30. And I'm going to create a value, the normalized value for the frame, by fitting the current frame, which goes from 1 to t frame, and make it from 1 to 0. I mean 0 to 1. Then I can just multiply this mask with this frame value. So initially every mask is going to be 0 because this starts from 0. But gradually the mask increase, sum of the part of the mask increases, which enables you to use 2 in the end at some part. But initially you're never going to get value 2 anywhere. So that's a simple introduction to the transitions, and let's see what happens. So first 30 frames. Oh, that was fast. It still have really quick transitions, which maybe I need to reset the simulations. Maybe not. Maybe this is going too fast. Maybe I can introduce for the f, I can use the power functions to make slowly raising up this f value. Okay, how's this? Yeah, a little bit better. Or just increase this 30 to like 60 frames. See what happens. Okay, so maybe it's a little bit better. You're going to use the full 60 frames to have a full potential for the wrinkle. And after this you're going to have these wrinkle simulations based on the noise map. Alright. Okay, so that's good. Let's try out the one that I just said, trying to procedurally control the stiffness of the cloth as well, based on the map, additional map maybe, so that I can also control the resolutions based on those additional maps. Okay, which could be interesting. Alright, so let's do that by, I don't know, I can reuse the current mask as well, or let's see. Yeah, maybe I can just reuse this mask, but with the different ranges. So I'm gonna call this mask 1, or let's call this wrinkle mask. And the other one, I'm gonna call it as resolution mask. Okay. Using pretty much the same thing, but trying to use something different for these mapping value. First of all, let's delete these offset. Let's make it from 0.3 to 0.7, and let's see what happens. Let's also rename this to Wrinkle mask. Let's have this second one as resolution mask. Okay, and let's see how it goes with the color. Okay, I'm going to use the point wrinkle to make these two colors combined. So the first one is Wrinkle mask. Second one is resolution mask. See what happens. Alright, so the yellow area is where you have the wrinkles. The green area is going to be the resolutions map. Maybe I think it's better if I make it flipped. This be the resolutions mask and this be the wrinkle mask. Yeah, I think this is better. Okay, and also let's tighten this up a little bit. Okay, and maybe if I don't have these, I don't know, maybe like these. Okay. It's a bit hard. Well, let me see. I still do want to. I'll replace this again. Sorry for that. Okay, and I might want to make this tighter. Right? And things that I want to make is to make these values as gradational as possible, which currently I'm not sure if that is, so maybe I can introduce some power functions to this. Oops. Yeah, maybe something like that. This is just a testing, not sure if it's gonna work, but let's see. So I have to mask here, and I have to rename the one that I referring to that value, which is right here inside a sub solver on the inside of Vellum solver. There, right there. So I have Wrinkle mask. Just gonna call it W mask, and another one is the resolution mask. Okay, and these are the wrinkle mask. Now things that I want to do is to control the bending stiffness using this resolution mask. And since I am working on the stretch right now, I think I need to have another primitive wrangle to work on the bending. So let's refer to the same value on a second input and copy these value here. Okay, and what else do I need to copy? So in this case, I would like to change the stiffness, right? And the stiffness itself doesn't have the original value copied, just like the unlike rest lengths, I think. So rest lengths attribute will copy its initial value to rest length's original, which it's not going to be affected by the simulations, which is useful. But in terms of the stiffness, it doesn't have a copy. So if you change it during the simulations, you're not going to get any original anymore. So let's create the copy of this stiffness so that I can use it as a base value. I'm going to use the primitive wrangle for the second output, which is the constraints, and copy the stiffness to stiffness original. Like that, just like the rest length, which is handy, I think. Alright, now going back to the SOP solver, and let's change the scale of this stiffness based on this mask value. So if I set the scale to 1, that's the same. If I set the scales to 10, the bending will become harder, like a rubber, which gives you less wrinkles. If you make it smaller, you're going to have more wrinkles. Okay, so what I could do is to first of all create a scale value for the resolution mask. Based on this mask, I can have a value in between 1 to 10, I guess, for now. And make this apply to the stiffness. And I also need to make this to a bend group by copying the stiffness original multiplied by the scale. Alright, just like I did to the rest lengths. Okay, hopefully this works. So based on those attributes, what I'm hoping for is to have the resolution differences between the center of the noise map and the border of the noise map. Okay, let's see. Let's see if that's the result that I'm getting. Not so obvious, is it? Not really obvious, is it? So basically, I had a bending like these. Let me try multiplying it by 100 if it changes anything. Doesn't seem like it's changing anything. Let me try out by just multiplying 100 as it is to this value. Maybe it's a problem with the noise map. And if it's become now this doesn't seem to change much, does it? what if I multiply this to very small value? If I'm getting okay, well, it does seem to work. I mean, in this case, I am getting tons of wrinkles now. Maybe there are some limitations to the maximum value. Okay. Okay, in that case, I could start this from 1 decimal lower. Then multiply by scale from 1 to 10. Which is also related to the glue strength as well. Okay, it's not really obvious. I mean, maybe I do need to increase the resolutions of this sphere itself to have more effect. So maybe let me increase this to 80 for the frequency. See if I can have more changes, gradational changes for the wrinkle sizes. It's pretty hard to tell. Okay, it's not really obvious in my eyes, so let me disable the masking, temporarily disable the masking for this extend edge so that everything will be wrinkled, but I can see the differences between the resolutions. So I am going to just use the frame for now without mask. See if I can see the resolution masking result. Well, do I see any changes? Maybe. I mean, these areas looks a little bit bigger than the other areas, but not too obvious. Let me increase the scaling from 1 to 100. See if I get any more changes. I mean, this is the first try I do this, so not sure if it's gonna work. Well, so let's see. Yeah, well, I do see some resolutional changes. Yeah, these areas are having more details on wrinkles. These areas are a bit more scarce, but not too obvious, is it? It's pretty much gradationally changing. So, I mean, yeah, it does seem to work, but not too obvious to me. Well, at least it works. I guess by combining two noise map, I think I need to shift the mapping areas so that I can see more changes in between these two. Yeah, I think that was the problem. That was too close to each other. Well, at least it works, and I can also use post-processing nodes, something like Vellum post-process, to smooth out these gallery areas a little bit. For example, introducing some spatial blur to smooth it out a little bit. Or you could also make some subdivisions to make it smoother. And yeah, it becomes more like a wrinkle bowl. Okay. Let me go back to the Vellum solver to introduce back the noise map for the extension. Where was it? Multiplying F by W mask. And also change the shift between the resolution mask and the wrinkle mask. And maybe I don't really need the power functions for this one after all, but instead I'm going to create some shift. I don't know, I guess I can just shift the time as with some additional value. Maybe using the same offset, but for the time. Multiplying by 10 or 100 or something. Think I need to close this. Nope. Yep. Okay, let's make these simulations back again with 50 frames, 50 frequencies for faster simulations. Okay, now it becomes a little bit interesting. Yeah, some part you have more resolutions, some part you have higher resolutions on the wrinkle. Yeah, like it. Okay, let me look at the comment. Collisions and self-collisions contributing much to the overall look. I would try disabling them on the solver since they are expensive to calculate and see if they simulate enough. I guess the small wrinkle would probably clip into themselves, but still worth testing real quick. It's true. The self-collisions are taking much of the simulation cost, so if you disable it, I think it will be much faster to simulate. Let's see, without these collisions, what happens. Yeah, much faster, but there's going to be some problems somewhere around here, which is a bit dirty. Yeah. Well, it's getting messed up a little bit. Yeah, it's probably better having these collisions, which is pretty expensive, but yeah. Or maybe I can reduce the collision passes, hopefully. Yeah, it works in some. Better than nothing, I guess. And I mean, yeah, it doesn't seem to intersect to each other, and if I have these Vellum post-process, it will clean this up a little bit. Yeah, not bad, I think. Maybe disable for quick prototype only. Yeah, I think it's a good idea. For quick prototyping, yes, you're right. Maybe disabling it enable us to test out many parameters for sure. All right. Well, looks good. Looks good. Let me go till the end to see this gonna. Okay, well, so the base setup is like this. So what you could do after is to play out with these masking value, probably. I mean, you could, just like I showed you in the first examples, you could create a morphing, like mask based from the typography or anything. You could also change the base geometry. In this case, it's a sphere, but you could also use any geometry. I think something like test geometry, like pig head. Let's see what happens. I want to make the size of this pig head close to the sphere so that I don't need to modify parameters much. Okay. Now, obviously I don't have enough points for this pig head, so let's increase it using maybe subdivide. And probably it'll be better if those points are triangulated, so using open subdiv loop. So currently the sphere had 25,000 and this one has 46,000, so I think that's enough. Yeah, let's have 46,000 points and see what happens. Okay. Play it. Yeah. And in the end, I think I need to delete those the copied points. I think I can do that by deleting the points which named as glue. And this is the result. A wrinkled up pig. If I consider it as a painted toy, maybe this makes sense. Maybe. Alright. Okay, well, I mean, works. Alright, so let me try out additional mask and I'll just finish this live stream. Let me know if you have any more feedback, so if you want me to try anything else, I can try that. If not, I'll just implement some text morphing masking functions and I'll finish this live stream. Okay, so Let me look at what I created previously. Okay, so in terms of the masking, currently I have this noise map, but I could create additional map. I mean, it could be anything, right? I mean, it could also be pretty similar to what we have in these wrinkles. If you search for paint wrinkles on Google image search, you'll see something like these, and these shapes are looking like kind of a Voronoi like shape. So you could also use something like Voronoi to retrieve the edges of the Voronoi and use that edge to create a mask, and probably you'll get something like this as a result, which could also be interesting, or something like these. Yeah. Anyway, let's try the text one. I'm gonna use multiple number of font. Just choose any font you want. I'm just gonna use the basic font like Arial, and let's say A. Or maybe I'll use some random characters. J. I think it's also better to test with the character which has two island like I. To generalize the process. And I don't know, Q, which has a hole. Alright, so you have a basic geometry which has one island, you have two islands, you have geometry with the hole. It's I think it's a great test pieces. Okay, then I'm gonna use the attribute create node to create some attributes on each geometry, probably to primitive in this case, to know which one's which. I'm gonna use primitive attribute called index as an integer. The first one I'll set to 0, second one I'll set it to 1, third one I'll set it to 3, I mean 2. Okay, let's have another one as well. The last one, let's see, do we have some complex geometry? Okay, like this one. Yeah, percentage and 3. Okay, now let's merge these together. The first thing I'd like to do is to project these text onto a surface so that I can use it as a map, attribute map or mask. Well, I can just project it from front maybe. So let's change this to sphere so it will be easier to project it. Let's change the size so that it will fit to the sphere, or maybe I can use the match size component to this target geometry. And try to make it a little bit smaller than the original. I mean, first of all, I'll set the scale to fit, but then I would like to make it a little bit smaller than current, which I can just do it using transform node. From the center, I can say like 0.8 or 7. Okay, now if I change this to pig head, should also work in the same manner. Well, some of the characters are off, so maybe need to make this a little bit smaller again. Still a little bit off, but I guess it's fine. Okay, let's make this back to sphere. And now in order to project this, I also need to make this moved a little bit off the geometry. So I'll just move this to the front, which in this case a Z positive direction. With enough value, like 100. Now I'm also going to create a normal and try to use array node to project this onto a surface. See if it's gonna work. I think it's not projecting because normal is not facing these directions, so instead of using normal node, I'm going to create a custom normal map. I mean normal direction to project, which is -1 for Z. Then I can, think it just projected. Yeah. 4 points. Now there's some problem with these, some of these edges not projecting correctly. That is because I don't have enough edges for some geometry, so I think I need to remesh these to have enough edges. It's a bit hard to see. Let's recreate the normal to see the edges. Okay, let's reduce the target size toward remesh. A little bit smaller, yeah, somewhere around here. Okay, it's enough. Alright, now this is the initial setup for the typography for the morphing. Now what I would need is to create a map, the actual noise map, transforming morphing from the first to second, second to third, and third to fourth, with some specific or timeline based value, or maybe slider based value. Yeah, which I'll do this by using point wrangle for the geometry that I'm going to modify and put the text information to the second input. Okay. Let's create some morphing value here. Okay, so first thing first, I need to have some information. I need to choose which information to be used for the morphing. I mean, if it's time-based, timeline-based, or slider-based, or custom value-based. I think using frame-based value makes sense if you want to make an animation, so let's do that. Okay. Now I have another value code here which uses the frame, which defines the first transitions from the smooth to wrinkle. So I think I'm gonna use this as well for the initial setup. Use this first 30 frames for the transitions. So I'm going to copy this parameter and use it right here. Okay. Now, additionally, I need to set some frame value, how much time I transitions from one character to another character. So let's have another parameters for that. Let's say W frame. Let's say I want to have I don't know, 50 frames or 60 frames to change between one character to another characters. And I also need information how many characters that I have in total for the morphing, which will be better if I could get from the second input. And do we have that information? Well, I can promote these index value, which is on the primitive attribute, and get the highest value, and the total number will be the highest plus 1 because it starts from 0. Okay, so attribute promote primitive to detail, change this to max number or number of text. Okay, it says 3, but if you add it by 1 later, then that will be the total number of texts. Okay, so int num is detail num text plus 1. Alright. Now I think I have enough information. I can try to create some morphing value between one character to another based on the time. So in order to create a morphing value, I mean, what I just need to do is to create a mask based on those texts or characters. If I have this character, based on the distance from each point on a surface, if it's close to those characters, maybe I can set the mask to 1. If it's far away, then I can set the mask value to 0. So basically I need to calculate the distance from each points to each characters, and you need to choose one of the characters based on your current timeline. If it's, let's say, the initial time frame is 30, then the first 30 frames you're going to stick with the first characters, in this case J. Then in the next 60 frames you're going to keep this J, and on the next 60 frames you're going to be using the next character, which is I. And you might also need to have some time to transition between J to I. So maybe I can use the half of the frames for this W frame, 60. So 30 frames to be fixed on the current characters, another 30 frames to be used for transitions between two characters from J to I, or I to Q, or Q to percentage. Okay, so that said, let's create some value for that. Now, first thing first, let's assume you have a transitions between two characters, and in order to do that you need to calculate the distance between the points on the surface to each characters, the character 1 and character 2. So let's create two distances using XYZ distance to the second input, and to choose which character to calculate distance to, I can use a index filter for the group with a specific index value. In this case I don't have that value yet, so let's make it 0 for now, temporarily. D2 is the next character, so I can pretty much do the same thing, but with I plus 1, which will be the next characters. Okay. Now, if I have those two characters, distance to the characters, I can then combine these two to create a transitional mask value, or morphing masking value. Okay, so let's do that. First thing first, this is just a distance, so I need to convert it or normalize it to a value that I can use it for masking. So let's normalize this. Probably I can use a fit function starting with 0, and let's create a maximum value to control the edge blurriness. And if it's close to 0, which means if the points on a surface is touching to the geometry, then obviously you want to have a mask value to 1. If it's far away, you want to have 0. Same for the D2. And I also need to make this mind or min D value a little as a small value, so that I can control the edge blurriness to for the distance. Now I can test this out, test this D value, see how it looks like by applying this to a color, see how it looks like. So if I set it to D1, something looks like this, and if I increase this min d value, you're going to blur the edges. So maybe 0.25 is around good value. If I change this to d2, I'm going to get the next character mapping. And now what I want to do is to transition between these j and I with specific threshold value. Okay, so let's do that. Well, I can just use lerp between d1 and d2 with some threshold value. I'm gonna temporarily create a slider and see again, check this value again with the color, see how it looks like. Starting from 0 to t. Okay. Now it doesn't really look like a morphing to me, but currently, for now, it's okay. Now in order to make it more like a morphing effect, going from j to I, one idea I can use is to use an attribute blur. Okay, for this masking value. For example, making the blurring iterations to 10 will give you enough merging between these two values. And if you could control these step size procedurally based on timeline, I mean, you would want to have these j crisp as possible when you only have j or when you only have I, but when it's transitioning from j to I, you might want to have these merged or blurred result to make it more look like a morphing. So if I can control the step size value based on this threshold, which is being controlled by these t, might make sense. So if I copy this t value, paste it to a step size, now the step size that I want to have is going to be a value going from 0 and to 1 in the middle and then back to 0 again, which looks like a sine wave value with from 0 degrees to 180 degrees. So I think I can convert this t value to those sine wave value. I can multiply this by 180, then use sine function. That way, if I change this to 0, it's crisp. But then if it gets close to 0.5, you got the full blurring value. And then if I make it close to 1 again, it try to become crisp I. So becomes a little bit more morphing like transitions between the mask. Yeah, I mean, you can still control these values more. See what happens. Maybe that was too much. If I set it to 5, which also looks okay to me. So some small technique maybe you could use for transitions in terms of the mapping. Okay, now that I have these transitional details, it's time I will use the timeline or frame value to transition between j and I and q and percentage characters. Okay, so where do I do that? I think I need to replace this t by the time-based value. So let's create that. In order to do that, I need to create the time-based value. First thing first, I'm going to bring up the frame, which starts from 1, but I think in this case better if it starts from 0, so I'm gonna subtract by 1. Okay, and I'm going to bring this I value that I have here next to the frame, and this value has to be related to this frame value. If the frame is somewhere around here, maybe I is 0. If its frame is somewhere around here, I could be 1, and it increment based on the frame value, based on those conditions. So first thing first, I need to set the I to, let's say, f minus t frame, which is a transitional frame, and initially f is 0, so this is gonna be negative, so I want to keep this minimum to 0, so going to use the maximum function to keep it 0 if it's negative, and divide it by the W frame, which is going to be used to define in which state you are in. Okay, and finally you also need to set the maximum for the I. I mean, if you have a maximum number of 4 in terms of the total number of text, then I shouldn't go more than 3. So minimum, and number minus actually the I shouldn't go more than 2. I mean, the maximum number that I can be is 3. I mean 2. Wait, 2. I mean 2. Yeah, 2. Meaning it's the third number. That is because I have I plus 1 here, so 2 plus 1 is 3, and number 3 as an index is the maximum. So you should not have I more than 2. The 2 it should be the maximum for the I, okay, which is the third index. Okay. It's a bit complex, I mean confusing, but that's how it is. So these are conditions for the I, and see what happens. So starting from I, wait, why I? Maybe I'm doing something wrong. It should start from J. Okay. Maybe I did something wrong here. Okay. Well, one thing I missed is I think I need to make this integer value. Wait a minute. I think I need to do like that. Okay, so this initially should be 0 and divided by the frame and calculated floor, and the number should be, the maximum number should be 2. Okay, and what is this I right now? Let me check. Zero, yep. Okay, and I haven't changed this t yet, so this is this t is the next thing that I need to change. Okay, so I have now next I need to create this t value based on the frame. So float t is t will be used as a transitional value, okay, from index I to index I plus 1. Okay, and I wanted to start this transitions after half of the frame of this W frame. So let's see. F current frame value is F, right? And I am going to have the same value here, right? And calculate the modulus with the W frame, which will give you in between 0 to 60 or 0 to 59. Now I can fit this value, and from the half of this W frame to the end of the W frame, I can then make it from 1 to 0 to 1, which will be used as a transitions value. And if it goes at the end of the number, if the frame goes above the t frame plus number minus 1 multiplied W frame, which is the end of the transitional end of the text transitions, which means it fills all the text, then you could say you could fix the t to 1, meaning no more transition happening. Then I can replace this with that t. See what happens. So first 30 frames, nothing happened. Nothing happens, and then next 30, nothing happens, but next 30 you have transitions to I, then next 30 nothing happens, and next 30 transitions, next 30 nothing happens, and next 30 transition. Okay, so seems to work. All right. Okay, well, yeah, that seemed to work. Now I need to apply this attribute blur value, which in this case I was referring to the t parameters, but I don't have this t parameter anymore. So I need to replace this with something else. I want to refer to this t for here. So to do that, I guess I can just set this t to detail attribute. And just get that detail attribute here. input. Then multiply by 180 degrees and use it with sine function. Okay, now J, I, Q, and percentage n with some blurring transitions. Looks more like a morphing. Yeah, looks good, I think. You could always change these values to control the more blurring. Okay, seems to do well. I'll make this back 10. Okay, now that I have these mapping, currently it's being applied to colors, but I can, if I just change this to a mask, then I can just use it as it is for the later Vellum setup, I think. So let's do that. Just gonna place this as a mask and enable us to switch between the noise-based mask and the text morphing based mask. See what happens. Okay, I'm gonna change this to text based mask and check out the transitions. Well, one thing I forgot is that I used the name Wrinkle mask and resolution mask, so I need to do that as well. I need to rename this to Wrinkle mask. Now in terms of the resolution mask, I'm not sure. I mean, I can just say 0 for everything at this point, just a test. Yeah. Or maybe could be based on some integer value or I value. Could be interesting. So gradually, if you change the characters, you're going to increase the resolutions. That might be interesting. And in order to do that, I need to have some flow value based on I, which is being normalized from 0 to 1. What will be better? I don't know. I'll just say so this is the total frame, right? So I can say frame divided by this value and clump it with 0 and 1. Yeah, should do the job. Okay, and hopefully this will do the... Okay, nothing shows up. Is because I didn't use attribute blur for wrinkle mask. Okay, still don't get the color. Do we have that wrinkle mask? Okay, it's I do, but I don't see the color here. Maybe a spell mistake or something. Wrinkle. Oh yeah. What is? Okay, I forgot to place the underscore. Now, okay, there you go. Okay. The green one stands for the resolutions. Okay, I also need to change this to... Okay. So hopefully this works. Let's see. Let's get back to the simulation part. See if I'm getting any result based on those setup. J I well, the resolution, maybe I need to increase the resolutions a bit. Q and percentage. Right. It's a bit too big. So go back to the cloth and decrease this stiffness value a little bit. See what happens. Now this is a bit too much. 7. Okay, J. I. Q. And percentage. Alright. Well, it works, I mean. So, I guess it's time to organize all those parameters that I have everywhere to one place and finish this live. A quick variant of the characters will be to convert them to open curve to have wrinkles on the character's contour. I think that's a great idea. Thank you, always fine. Thank you for saying that. Well, let me gather all those parameters that I have and organize this a little bit. It's pretty much the end of the setup. Okay, so just gonna cover all those with a group network box. Now let's try to bring all the parameters that I could use to control the shapes and results. First of all, the shape inputs or shape switch. You could also control the mask map switch, which in this case from 0 to 1, this is also from 0 to 1. And for each mask you have several parameters you can control. So maybe I can give those. Maybe I can change this instead of integer. I think I can make this as a operator path. Oh no, ordered menu, and change the menu first one to noise, second one to text. Okay, and then for this scale, this is noise related value. And I think I want to show this only when I choose noise on this mask map. So I think I need to use this parameter, and I forgot how I use this. Think mask map equal to 1, hide it. I don't know if this works. Let's try. If it's text, I want to make this hide it out. Maybe I needed the semicolon. Nope. I think I'm missing something. Mask map equal. Nope. Let me check the conditional how I should write this. Just search for it. Okay, so I didn't need the semicolon, was it? Yeah. And I think I needed the space between these. Has to be equal. Yep, now it's gone. Now it's gone. And if I change this to noise, it appears. These, I don't know, I mean, this is too strict. Okay, another parameter, offset. I think I can make this maximum 0.2 and using the same conditionals when to hide it. And I think I can set this value as well for speed. Same conditions. Copy this value. Paste it here. Okay, that's for the noise. Now let's go to the text. It would be better if I can just type anything here and which will create these list of text automatically. Might be more smart. So let's say I have a string called text, which in this case hidden when it's been chosen by the noise. So if it's equal to 0, hide it. And for this text, I think I can make a multi-line from 1 to 10 or 5 to 10. Oops, didn't want it to hide it out. Now for these text one, I can say J, I, X, Q, percentage, just like I have it here. But instead of having those manually created one by one, I want to automatically create those characters by using these, using this parameter. So let's copy this parameter and try to use something like for loop to create a similar setup. Okay, at least I need one of those inside a loop, and I need to count how many characters that I need, or words I need in this case. So I can just count the lines, the number of lines from here. So let's do that by, how do I do that? I can have a detail wrangle, refer to the string, from the parameters, and not sure if I have a functions to count the lines of text. Let me check. So in order to count the lines, maybe I can just split the text into a bunch of split the text with each insert, so in each lines. In this case, if I can use split function for the text. Okay, let's try this one. Split text with a return key. Let's see if I got the value that I want here. Okay, check the detail. Okay, I think I have it, so that's good. Get text. Okay, now I can connect this to a for loop, get each text on each loop. But before getting to this, I need to know how many iterations that I need to do. I can just say I can just access to this detail attribute value here. Let's give a null. Let's call this text. Refer to that value. Okay, now for each iterations, I can check the detail attribute lines. Use that here. Okay, so in order to refer to that, maybe it's better if I have a new node named something like this and get the value here. Okay, so the function that I'm going to use is detail s each txt what's the name? Lines. And this will indicate the index number, which should be coming from this for each count. So another detail. And hopefully this will give you, oh, nope, didn't give you. Lines in parameter, path node reference, lines in parameter. Okay. The detail-s cannot use the third parameter. Okay, so to make it simple, I'm going to use another attribute wrangle here and just pick the right characters that I want. Get the iterations as well. What's this? First of all, get the iteration starting from 0, and then use that to pick specific characters or specific string. Then apply this to a attribute. Just gonna call it C for detail. Okay, I don't see characters here. That is because I need to make it array. Okay, now I have this. Now I can just refer to this C value here, just easier. And I don't need these anymore. Hopefully I'm getting, yep, the characters. And the index is the iteration value coming from for each count. So detail for each count, for each count. Okay, and there you go. And you get the same result as these, I think. Yep. Yep. So I can just delete those. And instead have this here. I think I have deleted one that I shouldn't, maybe. No. No. That's fine. Okay. So it becomes more versatile. You can now increase tons of lines by yourself. It's good. Next parameters. These are fine. Maybe you can control the scale, project for the scaling, projecting. I mean, you might also want to control the projecting directions, but that's too much for me. I'll just leave it as it is. And that's fine. Maybe, I mean, this is not that important, but yeah, just in case. Text remesh. It's pretty minor parameters. And what else? Text more. Yeah, these are the important part. So you have T frame, which comes from other places, and W frame, which is the how do I name this? One line frame per line frame. Okay, say from 0 to 100 you have this minimum distance for the this is a border blurriness which can be from 0 to 1.1, and that's pretty much it for these one, and maybe this one as well for the morphing blur strength, or how do I call these? Morphing blur amount. From 0 to 30. Okay, that's pretty much it. And again, you need to set these hide when value for each of the parameters related to text. Okay, let's check. So if the mask is text, you have all these parameters. If it's noise, you have these parameters. Okay, that's good. Let's go to the next one. I'm gonna create some separator. So next one, this is fine, this is fine. So you can, I think you want to control the base stiffness of the bending, which is these one. Not sure how I can bring this to the, I don't think I can drag and drop these value here. Nope. So I think I need to make this value, similar value, right here. How do I do that? If I open up the parameter input, parameter interface for this one, and look for that parameter. Where is it? What is it called? Stiffness? No, the stiffness for the bend. The bend. Where is it? There you go. Stiffness. I think this is the one. If and this is the multiplier. No, that's just a label. I need the menu, which you can change. What is multiplication here? And what does this value called? Bend stiffness expression or something, exp. Then stiffness exp. Where is that? Where is that? Oh, okay, this one. This wasn't a label. All right. So if I bring this up here, nope, didn't work. I was hoping if I can bring this up here, if I copy parameters, if I can paste it here. Nope, doesn't work. This is the ordered menu, right? What if I just paste it here? Does it? Nope. Nope. If I duplicate it here, duplicate parameters. If I, nope. Copy this parameter, paste it. Okay, there you go. Okay, now I can rename this. And how does this called? I want to call this bend stiffness. Okay, and gonna copy this one, paste it to here. How do I paste relative reference? There you go. All right. So for the close constraints, that's the only things that I wanted to change. Next one, glue. Maybe nothing to change here. I mean, you could change these glue constraints stiffness. You can make it lower to have more weak connection between surface and more wrinkles. But I'll make it stay as it is for now, since I didn't test it. This is fixed. This is also stay the same. Going inside a solver. Yeah, I can change this value here. This is the transition frame. Okay, and not anything else. Yeah, I can also change these as well. So bending stiffness map. Minimum bend, maximum. Let's say for now minimum is 1 and maximum is 10. And bring it here. No bend scale. Okay, that's pretty much it, I think. And finally, if you need a subdivisions in the end, maybe you could also have this as a parameter. Okay. And maybe for testing, you could also maybe disable these collisions. So I can have prototyping toggles. To disable or enable the collisions. So if it's on, I want to disable these, so maybe I should change the name. Okay, that's pretty much it. And for the sub D, yeah, I think it's fine. And if I play it, okay, this is without the collisions. Right. If I enable the collisions, let's also check with different shapes. If I change this to peg head, what would happen? I mean, it's mapping to the front, so something wicked this way come. Yeah. Can't really see the text anymore, but I guess it's working. Okay, so seems it's working. And this should also work with different text. For example, X, ABC, XYZ. Something like that should also work. Now the in terms of the resolutions, it's a bit too small to see. Maybe I need to increase the subdivisions to see the result, or make this a bit smaller, or in this case I guess I need to increase the whole resolutions, the shape. Let's see the result. ABC, you can really see it. And should become XYZ. Yep. Okay, yeah, I think it's working. I make this back to okay, so that's pretty much it. Alan, as a comment, could you optimize this by doing something like if mask is equal to 0 and stretch equals to 0, then disable sim. each point. I'm not sure if you can disable the simulations per point. Is that possible? I'm not sure if that's possible. I mean, that I don't really know. I mean, you could turn off the collisions based on those conditions, but other than that, I am not sure if you can disable the whole sim. But at least, yeah, I could disable the collisions thing just like I did here, like these one, and maybe I can add these conditions to the points where the mask is equal to 0, which means it shouldn't really collide with anything, probably. Let's try that. So I'll copy this value, and which needs to be done on the geometry side, not the constraint side, so I need another solver actually, which works on the geometry itself, which has an attributes for the points like these, something like disable external and disable self. So I can then refer to the mask just like I referred to this map. So I'm gonna copy this okay, then get that mask value, wrinkle mask, UV sample, and let's see, wrinkle mask, right? Okay, and what was the name of the attribute? Okay, so if wrinkle mask is small enough, close to 0, then disable it, else don't disable it. Let's check the speed having these and not. Okay, so let's try out with having this one without subdivisions, and done. Let's make the ball resolutions to 70 is fine. Let's count the performance. So this is with the condition when the mask is close to 0, disable the collisions for those points. Let's see. Well, I'll test till frame 60. Okay, and that took around 14 seconds, or just look at the Vellum, 12 seconds. Okay, now let's go back and Now I'm going to disable this one. See what happens. Okay, start till 60 frame. And it didn't really change, so maybe just turning off the collision doesn't work and doesn't make the performance well. Not sure if you can completely turn off the sim per points. That I don't really know. Probably I don't think you can, but maybe there's a way. So this didn't really work. Just gonna delete it. You can disable L stop I at stopped 0. Ah, really? And that's for the point, is it? Let's check it out then. Is it I at stopped? Is that okay? Let me check. So I'll just say everything should be stopped just to test if nothing is gonna happen. If that works, then yeah, actually it does seem to work, but let's also monitor the performance. Let me reset this. Let me turn this off temporarily, reset the simulations, turn this back on, and look for the performance. So if I play it till 60 frame again, yeah, the simulation is not running, but it doesn't affect the performance to me, is it? Maybe a little. Still goes to 12 seconds, so maybe it didn't really affect the performance, even though if I can stop simulations. I see. Well, but that's it. I didn't really know about this attribute, so maybe it could be pretty useful for other usage. Thank you for this information. I'll keep it somewhere. I'll just disconnect it, leave it here so that I can reference this later. Okay. Well, let me know if you guys have any more questions. If not, I think I have shown stuff that I wanted to show for today. Things that I wanted to test. So I'm pretty satisfied with the result. The other thing you could do is try out with the border of some geometries. So the idea is to disable simulations where mask is 0, so those points aren't in the simulations. The idea is to disable simulations where mask is 0, so those points aren't in the right. It's true. I was hoping that method could make the performance a little bit better. Unfortunately, it didn't. Probably due to some system on the Vellum side. Not sure how that how is it really working. Pretty much, I kind of want to know how exactly Vellum works algorithmically, so that I can reliably change the performance or constraints customly if I wanted to use more physically based simulations, but it's a bit black boxed how it's been controlled. It's a bit hard. Alright, let me also try with the boundary of some geometries and just finish this live. I could test out the text boundary, I guess, just like I had on the comment. So I have these text here. And laid out here. Maybe after laying on a surface I can then trim out or dissolve the inner edges using polypath and divide node. And let's see if that will change anything. Yep, did. Okay. Yeah, so it does do something. Okay. Not bad. Let's make a switch node to switch between these two. And I think I can have that as additional parameters for the text. For this one, maybe I can just use it as a toggle. Alright. maybe I have a comment. Maybe if it's something where we disable the point, but the constraints are still calculated or something. Maybe, yeah, I think so. I'm not super familiar with the inner working either. Yeah, that's probably it. Constraints still seems to work at. So maybe that's the reason. And I don't really know if you could totally disable the constraint itself. Okay, well, in terms of trial, I think this was enough. I think I'd like to finish this live here. Thank you for watching. As always, thank you for coming and thank you for all the comments. It's really appreciated. I will, as always, I'm going to upload the files that I created today, this one, to a GitHub, and you can download from either from Patreon page or from YouTube description page. I'll paste the link later. You can download it for free. So hopefully you could play out with it, and if you have any feedback, maybe you can later post some comments again. That will be great. Okay, so that's it for today. Thanks for joining. Hope you find it interesting. I'll probably do something else next week as well with different topic. So see you then, and good night. Have a good weekend.